All right, thanks for tuning in once again to check this out mathematics. And in this series of videos, we have been talking about the Pythagorean theorem, Pythagorean triples, and three formulas that generate Pythagorean triples. And so now we are at part 4, where we will talk about the third formula that generates Pythagorean triples, a, b, and c, where a squared plus b squared equals c squared. And so let's remember that we talked about these two previous formulas that generated Pythagorean triples, where you have a basis of m and 2m plus 1 and 2m plus 2m squared, and 2m plus 2m squared plus 1, and that will give us a Pythagorean triple. And then we had a basis of m and n, and we went through this formula, 2mn plus 2mn and m squared minus n squared and m squared plus n squared, and that also gives us a Pythagorean triple, where a squared plus b squared equals c squared. And so now we're ready to talk about the third formula that we are presenting in this series of videos. And to do that, we are going to introduce some more Pythagorean triples. And so let's have a Pythagorean triple, A, B, and C, where we have 12, 35, 37. Okay, so this is our Pythagorean triple, 12, 35, 37. And let's show that that is a solution for the Pythagorean theorem. So we're going to say a squared plus b squared equals c squared. And we're going to take the a value, 12, and square it. And then take the b value, 35, and square it. And so now 12 squared gives us 144. And then 35 squared gives us 1225. And then if we add those values together, 144 and 1225, we will get 1369. And if you check it out on your calculator, 1369 is 37 squared. 37 times 37 is 1369. Okay, so we have a Pythagorean triple, 12, 35, 37. And let's show another Pythagorean triple that will help us in presenting this third formula that generates Pythagorean triples. And this one is 33, 56, 65. This is a Pythagorean triple. And let's show that is true. So a squared plus b squared equals c squared. And the a value is 33. And so we're going to square that. And the b value is 56. So we're going to square that and add them together. And so if you multiply 33 times 33, that gives you 1089. And then if you multiply 56 times 56, that gives you 3,136. And then if you add those squared values together, that will give you 4,225. And 4,225 happens to be 65 times 65. So now we have another Pythagorean triple that will help us to present this third formula that generates Pythagorean triples. And so, getting my script ready here. Let's say that we have this basis of 1 and 5. And then let's manipulate those numbers in this way. Let's multiply those numbers. 1 times 5. And then double that result. And so that will give us 10. And actually there's more to this part of the formula. So we're going to multiply the numbers, 1 times 5, and then double the result. And then add twice the square of the first number. So twice the square of the first number. So our first number is 1. And our second number in this basis is 5. And we multiplied those numbers and doubled them. And then we added twice the square of the first number, 1 here. And so now this gives us 10 plus 2 equals 12. Okay, now let's manipulate the numbers in another way here. Let's multiply them together, double the result, and add the square of the second number. So we're going to multiply the two numbers together, 1 times 5, double that result, and then add the square of the second value. And so that gives us 10 plus 25, and that gives us 35. All right. And now let's bring this all together. We're going to multiply the numbers, double the result, add twice the square of the first number, and the square of the second number. So we took the two numbers, 1 and 5, and multiplied them together and doubled them. and then we're going to multiply that, we're going to add that to twice the square of the first basis value, and then add that to the square of the second basis value. And so this gives us 10 plus 2 plus 25, and that gives us 37. And so with a basis value of 1 and 5, and through this algebraic process, we have arrived at a Pythagorean triple, 12, 35, 37. That was presented as a Pythagorean triple just a few moments ago. Okay, so this is the third formula for generating Pythagorean triples. And let's formalize this formula by writing it as some variables. Okay. All right, so let's begin with our basis. This time it's going to be 4 and 3. And we're going to say those are the S and T values. Okay, and so now let's remember what we did here. One of the things that we did was we multiplied the two numbers together and doubled them and added the square of the second value. And so let's say that here. We have twice S times T plus T squared. So we multiplied the two numbers together and doubled them and added the square of the second value. One of the things we did. And so then this would be 2 times 4 times 3 plus 3 squared, and that's going to be 8 times 3, that's 24, plus 9, 3 squared, so 24 plus 9, and that gives us 33. Okay, and now one of the other things that we did in this process is we multiplied the two numbers together, doubled them, and added twice the square of the first number. And so let's do that. That would be multiplying the numbers together, S and T, and then doubling them. So we have 2 ST, and then add twice the square of the first number. So twice the square of the first number, the S value. Okay, so let's bring that together. That's 2 times 4 times 3 plus twice the square of the first value. Okay, so twice the square of the first value. And so that gives us 2 times 4 is 8, times 3 is 24 again. And then here we have to square the 4 first, according to the order of operations, and then multiply that by 2. So that would be 4 squared is 16, and multiply that by 2. And then we would have 24 plus 32, and that gives us 56. Okay, just enough room on the slate here. Okay, so we have these two algebraic manipulations of our s and t value to give us 33 and 56. And now we're going to bring those two manipulations together and have 2st plus t squared plus 2s squared. And so that was 2 times 4 times 3 plus the second value, 3 squared, plus twice the first value, s, which is 4 squared. Okay, so multiplying the two numbers together, 4 times 3, and doubling it, and then adding the second value squared and twice the first value squared. That's just what we had done on the previous basis of 1/5. And so let's figure this out. So once again, 2 times 4 times 3, that's 24. And 3 squared is 9. And then 4 squared is 16 times 2 is 32, as we had previously. And if we add 24 plus 32, remember we're getting 56 there, and so 9 more will give us 65. And so now we have that Pythagorean triple, 33, 56, 65. Okay, so there's our third formula that generates Pythagorean triples. And we got a nice Pythagorean triple here, 33, 56, 65. That's palindromic. Okay, the 56, 65, 56, 65, and the 33. Palindromic Pythagorean triple. Who comes up with this stuff? Okay. So let's write this down here. We have our third formula that generates Pythagorean triples, and it works like this. You take a basis value of s and t, okay, and you multiply those values together, 2st, multiply the values together and double it, and then add the square of the second value, and then we would multiply the numbers together and double it, and add twice the square of the first value. And then we would multiply the numbers together, add the square of the second value, and twice the square of the first value. Okay, and so this is a formula that generates Pythagorean triples, and you may have noticed I've been writing this one first or this one second in our manipulations, and that's just because this formula generates an A, B, and C, where A squared plus B squared equals C squared. And this formula for generating Pythagorean triples has something very interesting to it. You would remember that we had 1, 5 as our basis that gave us 12, 35, 37. And then 4, 3 that gave us 33, 56, 65. And what you should notice here is that the first number can be smaller than the second number, or the first number can be larger than the second number. And so depending on which way it is, smaller or larger, then you can have these the A and the B values turned around, so that in that way the A value will be the A, B, and C value will be order from the short leg and the long leg and the hypotenuse. Okay, and so what we should also notice is that this is all addition. So there are no restrictions on the S and T values. That is, the S value can be larger than the T value, or the T value can be larger than the S value. And so here's something for you to check out. We presented that 1, 5 will give us this 12, 35, 37 Pythagorean triple. But now if you happen to go through the process with 5 and 1, you will get a different Pythagorean triple. That's 11, 60, 61. And if you, we also showed that for 3 gave us the Pythagorean triple 33, 65, 56, 65. But if we happen to go through the process with 3 and 4, we will get 40, 42, 58. as a Pythagorean triple. And that is a multiple of the Pythagorean triple, the primitive Pythagorean triple, 20, 21, 29. And so this Pythagorean formula, this formula that generates Pythagorean triples here, if we choose S and T, and we go through this process of, say, 1 and 5 as our S and T value, we'll get 12, 35, 37. But if we happen to put the 5 first as S and the 1 as T, we get a different Pythagorean triple. So I encourage you to check that out for yourself and see that those are true. Okay. So now we have presented 3 formulas that generate Pythagorean triples. And if you've liked these series of videos, you can give me a thumbs up and subscribe to my channel. That's Check This Out Mathematics. And we have one more video to do, and I might make a couple prequels later on. But we have one more video to do where we are going to check this out. What's behind me in this 3, 4, 5 triangle. All right, thanks for tuning in. I'm Mr. Donald. I'll see you again.